points. So the formula for the cosine distance is 1 minus d1 into d2 divided by norm of d1 into norm of d2. So first we are going to find the d1 into d2, that is the dot product between the point d1 as well as d2. So how we are going to find the dot product, which this is the point of d1 as well as this is the point of d2. Now we are going to find the dot product between these 2 points. That is, we are going to multiply the first element with the first element plus the second element with the second element plus the third element with the third element. Like this, we are going to multiply all those respective elements and then sum of all those values. We get us the value for the dot product. So this is the value, that is d1 and d2. So this is the first element of d1 as well as the first element of d2. Multiply both this value, that is 5 into 3 plus the second element is 0 into 3 plus the third element is 3 into 2 plus the fourth element is 0 into 4. Likewise, we are going to multiply the first element with the first element of the second point. By simplifying this, I get an answer as 25. That is, the dot product of d1 into d2 is 25. Next, in the formula, we are going to find the value of norm d1. So the formula for the norm d1 is square root of sum of square of all those values. So we are going to take the square all those values, then sum the all those values, then we are going to take the square root of these values. That is, the first value is 5. So we are going to square this, that is 5 square plus 0 square plus 3 square plus 0 square plus 2 square plus 0 square plus 0 square plus 2 square plus 0 square and 0 square. By taking the square root, then we get an answer as, by squaring this, we get an answer as 25 plus 9 plus 4 plus 12. By adding all those values, I get an as root 42. So the value of norm d1 is root 42. Next, we are going to find the norm value of the point d2. The norm d2 also we are going to take the square root, then we are going to sum of square of all those points which is present in the point d2. So the values are in d2 is 3, 0, 2, 0, 1, 1, 0, 1, 0, 1. So we are going to square all those values. By adding all those, then we are going to take the square root of this. By taking the square root, that is square root of 3 square plus 0 square plus 2 square plus 0 square plus 1 square plus 1 square plus 0 square plus 1 square plus 0 square plus 1 square. By simplifying this all those value, I get a value as root 17. That is, the norm of d2 is root 17. Now we are going to substitute all those values in the formula. So the formula for cosine distance is 1 minus d1 into d2 divided by norm of d1 into d2. So the value of d1 into d2 is, that is the 25. So substituting this value in the numerator. Then in the denominator, the value of norm d1 is, that is root 42 and the norm of d2 is root 17. Substituting all those values, by simplifying this, I get an answer as 0.9361. Then the value of 1 minus 0.9361 is 0.0639. So this is the value of cosine distance between the point d1 and d2. So using the formula 1 minus d1 into d2 divided by norm of d1 into norm of d2, I get an answer as 0.0639. So the second problem is, so we have to consider two vectors. So the first vector is A, that is equal to 1, 2, minus 4, 3, minus 6. And the second vector is B, that is 1, 2, 5, 2, minus 3. So we have to calculate the following distances. So the distance of first one is d1 of A, B, and the second one is d2 of A, B, and the third one is d0 of A, B. So the first one is d1 of A, B, that is the Manhattan distance, and the second one is Euclidean distance, and the last one is d0 of A, B. So first we are going to calculate the d1 of A, B. So that is, we are going to find the Manhattan distance. That is, so we are going to substitute the first element with this first element by subtracting the first element with the first element and by taking the modulus, and then we have to take the second element, that is the 2 minus 2. Also we have to take modulus for the second element also. Likewise, we are going to take the subtract as well as taking the modulus. We get an answer for the d1 of A, B. That is the modulus of 1 minus 1 plus the modulus of 2 minus 2 plus the modulus of minus 4 minus 5 plus the modulus of 3 minus 2, and the last one is the modulus of minus 6 of minus 3. By simplifying this, I get an answer as 30. That is the value for the d1 of A, B. So the value of d1 of A, B is 30. And the next we are going to calculate the Euclidean distance, that is the d2 of A, B. So the Euclidean distance is, how we are going to calculate the Euclidean distance is, that is, again we are going to take the whole square root for the second element. So the second element is 2 and here also the second element is 2. So by subtracting these two and then taking the square, we are obtaining the value as 2 minus 2 the whole square. Plus likewise we are going to take the remaining value also. By simplifying this, I get an answer as root of 91. So the value of root 91 is 9.54, which is the answer for the D2 of A comma B, that is the Euclidean distance. So next we are going to calculate the value of D naught of A comma B. So the formula for finding the D naught of A comma B is we are going to count the number of unequal positions. Here in the first position the value is 1 and in this D distance also the first value is 1. In the second value the position is these 2 and in here also the second value is 2. But in the third value is minus 4, but here the third value answer is 5. So here in the position of 3, 4, 5 we are obtaining the different values. So we are going to count the unequal position. Here the unequal positions are obtained in the position of 3, 4, 5. So that way only I am writing here as a position 3, 4, 5 are unequal pairs. So by counting these three numbers, that is we